Hi, welcome to our math. Today I'm doing a series of videos on exponential functions, and in this video we're really going to look at the graphs of exponential functions. So here we have two graphs. An exponential function is characterized by going closer to some, this is called an asymptote. An asymptote is a barrier that a graph approaches but never crosses on one side and exploding on the other. And here we are exploding down and our asymptote is over here. In both cases, the asymptote is the x-axis. Okay, our formula is f of x equals ca of x, where c is our initial value. And the initial value is where we cross the vertical axis. And a is our growth or decay factor. It's what we multiply to move forward. Okay, so for this first one, this is where we're crossing the vertical axis. This is the positive direction, this is the negative direction, which means c is greater than 0 because we cross above the x-axis, the horizontal axis. Now, notice I'm not saying because c equals 3. We're not trying to get that specific. I don't need the numbers in here. What I really need is the general pattern of what's going on versus this one where c is less than 0 because we cross below the horizontal axis. Okay, now a is what we're multiplying by. If we look going forward, here's when we're at 0, here's when we're at 1, here is when we're at 2. As we go forward in time, these lines are getting bigger. Well, if we multiplied by 1, everything would be at this height. Because this is bigger than 1 and even bigger than 1, it means that a has to be greater than 1. And it's because we are moving away from the horizontal axis, moving forward. We read from left to right, so we read this way. As we move forward in time, we're getting further and further away. Versus this one, as we move forward in time, if this is our one line, again, each of these is smaller. So this one, and I'm going to make it a little more interesting. I'm going to say a is less than 1. We're also going to say it's greater than 0 because your factor cannot be negative. If it were, we would bounce back and forth in a really bizarre, smooth graph. Okay, so it is between 0 and 1 because the graph moves towards the horizontal axis, moving forward. Okay. Next, I want to do the domain and range of these two graphs. So I'm going to quickly come back so we can really see these graphs. Domain is talking about the horizontal axis. And notice with this arrow, we're going forever left, and with this arrow, we're going forever right. With this arrow, we're going forever left. With this arrow, we're going forever right, which means the domain in both cases is all real. Now, when you write the domain, you could say all real. You could do double bar R, which means the same thing. Or you could do interval notation, which would be negative infinity to positive infinity. Or because the graph has this labeled as x, you could also do negative infinity is less than x is less than positive infinity. So you can do it verbally, symbolically, interval notation, or as inequality. And all four of these mean exactly the same thing. This is the one that I tend to use in my class, but honestly, I would accept all of those unless it's specifically told. Very often, especially with online homework, where the computer has to grade it, where you get really used to being told exactly which method you're supposed to use. But when you're doing it paper and pencil, it can be any of them. Okay, range. Range is your up and down values. Well, I already told you this was an asymptote that we're not going to cross, so we're never going to equal 0. But this says we're going to go forever up. So that means for my range for this one, I can either say r of x is greater than 0. It can't equal 0, so I don't have an equal sign there. I can say interval notation, where I have 0 to positive infinity. Again, this is the one I tend to use in my class, but I'm really allowing either of them. We also could say r is greater than 0. You don't need the function notation. Oh, it should be a lowercase r. R is greater than 0. We know this because it says right up here, r of x, so we're told our output variable. Okay, and then for this next one for our range, again, we have this asymptote, this barrier we can't cross, but we're going down from there. So here's where the biggest mistakes are happening, so pay attention. In this case, we either have r of x is less than 0, r is less than 0, or again, I like interval notation. Make sure you do negative infinity to 0, because on a number line, negative infinity is always on the left and positive infinity is always on the right. And so you have to keep the negative infinity on the left in interval notation, and you have to keep the positive infinity on the right in interval notation, or it is incorrect. This has to be in the same order it would be on a traditional number line. Okay, I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you in the next video. Thanks!